Good evening, everyone. We will start. In the last session, we have started with the file handling concepts, and we have seen there are two different types of streams which we can use for file handling. First one is the byte stream. From byte stream, we have already completed the input stream class, that is file input stream class. We are going to see today the output stream classes. From output stream, different classes which are going to use for writing data into file or appending the data into file. We are going to see the file output stream class. Okay, this is the byte output stream classes. The output stream class have it implements the closable and flushable interface. It has few methods. For example, the close method, which is used for closing the stream. Flush method, which is used for outputting the flush or flushing the buffer data. Okay, so that it will write the data clearly. Then there are three different write methods, overloaded methods. Same as the read methods, we have three different write methods. The first one is used for writing a single byte of data. Single byte will be written using the write method. Second one is the write method with the array, byte array. It writes the data from the byte array to the output stream. And the third one is the write array with the byte buffer array, int offset and int number of bytes, same as the read method, the third overloaded method, where you can pass the data which you want to provide write from this particular buffer from offset, and how many number of bytes you want to write on the file that you can specify here into this write method. So we will start, we will see one example of writing data and appending also, how to open a file into write mode and append mode. So we are going to use file output stream class, which is into java.io package, which is the child class of output stream class. So because we are going to perform the file operations, that's why we are using this file output stream. I'm creating one object of this is equals to new file output stream. There are multiple 4 to 5 constructors are there. We are going to use the string name, and this is the append boolean value. Okay, I'm removing this for now, and here I am giving the name, that is abc.txt. We have already created this file. Okay, so we will see that if we are writing how the data gets written into this abc.txt. Okay, first we will see, I will change the name here. Example.txt. Okay, I'm creating the example.txt. So when you are opening a file into write mode, if this file is not present in your system, that means the given path, whatever the given path is, it will create this file and write the data into it. Okay, so this throws the exception, which is the file not found exception, and I'm using the try catch for this particular. We need to close this also. So what we will do, we will directly use try with resources. I will add this object into this particular try block, remove the semicolon, close the bracket, and open the curly braces. Okay, so that this object is closed, gets closed automatically. The stream gets closed automatically. I'm adding the catch clause, one more clause, that is one IO exception again, which will be thrown from this. Okay, now we will start writing. So you know that how to write a file. So what I said, this, whenever you're only giving the name of a file, then it will get open into the write mode. By default, it will get open into the write mode. When we are opening the file into write mode, if this file is not present in your system or the given path, it will create the file and write data into it. Okay, so I am writing using this object fout.write method. First, we will write a single byte of data, because first data is this. Okay, I'm writing 14 byte. Okay, so it will write the 14 into the file. It will create the file and write the data. Second one is we will use fout dot write. I'm going to use the second write method with the array. So we will create the array post here. That is a byte array. And of size 10 I am creating. Okay. And I'm going to save the data into this array, which I want to write. Okay. So what we will do, we will write one string input. Okay. We will write one string statement. This is example of writing data into file. Okay, this is the statement. And I want to convert this particular string into bytes array. Okay, so we can use this array is equals to s dot get bytes is the method which is used for getting or converting all this string data into the bytes, and we can store it into this array, and we can pass this array here into the write method. So it will write the byte. So we are writing a single byte into the array. After that, we are writing this byte. So we are not giving any new line character here. By default, it will never write the new line character. If you want this statement should be written on the new line, you should write externally or explicitly the new line character here. Okay. Now I want to write the same data, but with the offset and number of bytes. So I will use the same data we will use. Okay. Same array we will use, but only the third write method. Write here, I'm going to pass this array. Then the offset, I want to start from 5th index, and the number of bytes are 10 bytes only. Okay. Let's see whether our file gets written, whether the file gets created here or not. I'm executing this. Okay, we are not displaying anything on the system.out.println statement is not there. It will automatically get terminated. We are not displaying anything on the console. Okay, so we have not yet written any statement of system.out.println. That's why nothing will get out on this console. We will check directly into the project folder, go to the project folder, refresh it. So you can see the example.txt is get created, and I am checking here. So this is the 14 character. Okay, whatever the 14 character, I have written the byte. Okay, we will, if you want to write it into character, you need to convert it or cast it into character. So we on the second line, we have written this statement, which is into the string format, and we have converted it. And the third one is with the offset and number of bytes. So same thing we are written here. Okay, we have done different ways. If I change the data and use the same, if I want to convert it into character, okay, I'm using character instead of this 14 as a byte. Okay, and I'm using the new line character here. Fout dot write with the new line character. Sorry. You can do in this way also, because I want to add the new line. You cannot directly use the string format of new line character. So we have to convert it into bytes. Okay, so I'm using get bytes method again here for just adding the new line character. Now here you can see that this is the changes I have done to this particular program. Now I'm again executing this. So when you are executing the same file, now this file is already created. So whenever you are opening this file into the write mode, so we are opening this into write mode. Okay. So when we are opening this into write mode, the contents of the file gets replaced. Okay. With the new one, it will get replaced. Always it will replaces the data from your file. It will never append the data. It will not keep the data as it is. Okay. The previous data will get replaced and the new data will be displayed. So you can see here, this is the new data, which I have added the new line character. And okay, this is for 14, it is showing something different. I will change to.
It is only dot get bytes.
Yes,
only
get bytes is the method.
Yes.
It is a string method.
It is not s dot get bytes.
This is s dot get bytes. I have saved this data into the array.
Array.
And this is a new line character. So you can directly use for this particular string also directly you can use the get bytes method using dot operator, because this is a string, right? So you can use on string, you can directly use the get bytes method using the dot operator. For simplicity, I will use this brackets. Okay, so this is nothing but a string. Okay, so I will execute this again. We will go to the example.txt. Now you can see that the question mark is there because I have changed the ASCII code, okay, character, and you can see that this is the output. So data is getting replaced. It is not appending it. Okay, so this is how the example.txt, or how we open the file into write mode, and how to write the data into the file using output stream class. Now we will see one more.
Suppose if I want \t, again f out dot write of \t dot get bytes, right?
Yes.
Okay.
So whatever string data you want to write, you need to convert it into bytes first, and then you can write it into the file. Because this is a byte stream, it always uses byte data. Okay, that's why. Now we will see how to open a file into append mode. So I'm using the try with resources, same. Now we will again create the file output stream object is equals to new file output stream. Here we will pass the name of the file or new file object also. Here I will show you the new file object. New file with the string file name. So we have already created the abc.txt file. Okay, I will open that file abc.txt, or you can open the same file also into the append mode. So whenever you want to open a file into append mode, we have one more parameter here into the file output stream constructor, not here, into the file output stream constructor. Okay, that is Boolean true or false. So if you want to open the file into append mode, you need to use true here, so that the file gets open into, sorry, here. So the file gets open into the append mode. Okay, so file output stream constructor has two parameters. First one is the name of the file, and second one is the Boolean append value. If you are passing true, then the file gets opened into append mode. If by default it is false, okay. So if you are not providing anything like here, it will be open into write mode itself. Now we will add the same catch blocks as it is, because the same exception will be thrown. Now here we will use the same write method to write the data. I am writing character 96. Okay, I'm writing character 96. This is the error. One second. In bracket is missing here. Okay, now I'm writing this. That means we have already opened the file into append mode. That means this data gets appended to the abc.txt. It will not directly replaces the content. Okay, so here I am write one more data. So using about.write, this is example of writing, appending data. file. Okay, dot get bytes, because we need to convert it into bytes. So this data should be written on the new line. So I am writing the /n here into the same string, executing the example again. And now the example.txt, we have already seen the same. Okay, now we will open the abc.txt file, which we have appended the data. So you can see this data is appended here, and this dash is also added because I have use this character 96 here. Okay, so whatever the 96 is related, it will just add that byte is converted into character. Okay, so if you again execute this, again the data gets appended one more time. Okay, so D is the character gets appended and this statement is appended because we have opened this file into append mode. Okay, so this is how the read and write operations on the file works. So for read purpose, you need to use read methods. For writing purpose and appending the file, you need to use write methods. There is no append method. You need to use the write method itself. Just the thing is, you need to open the file into read mode or append mode. So append mode is you can open it the file into append mode using Boolean value into the constructor. Clear? Any doubt? Okay, so similar to this, we have a character stream classes. The character stream classes is reader and writer. It also has the same type of methods. Only the difference is it is the input for this is character buffer array. Okay, only the difference is character buffer array. It also uses the same data. It also internally it uses the byte stream itself. It is an abstract class and it implements closable and readable interface. Same character stream class for writing purpose is the writer class. It also has the same methods. Only difference is there are two more methods added here with the string parameter because it is a character stream. That means you can directly write the string data into the file using this writer class object. Okay, so abstract class, it implements closable and flushable interface as well as appendable interface. Here we can append the data in a similar way where just now we have seen. So we'll do one program, reading and writing together. Here, reading and writing together, we will see the reading and writing together instead of this separate files. I will change the file name. Reading and writing a file. Okay, in the main method. Now we will create. So reader and writer classes are their parent classes, and we have file reader and file writer. File reader is equals to new file reader object we will create. Okay, inside the file reader, you need to pass, because this is a character stream class and internally it uses the byte stream itself. So to the file reader, again, same as the file input stream, you can pass the name of the file. So I am here passing the test.txt. I'm opening this file for reading purpose. Okay, file reader object is this, right? So I am opening this file into read mode. So this, we also need to close this. That's why I'm using here the try with resources, adding the catch clauses, file not found and IO exceptions. All these throws the IO exception. Okay. It also has the same type of methods which reads the bytes or characters from your file. Okay. So same, we will read the complete file. We have while loop. Okay. So we will use fr.read. fr.read is not equal to -1 unless and until this is returning -1. We just need to read the file. System.out.println, not println. It should be print, and we need to, now you can read the file fr.read. Sorry, we have already read this. I am storing that into one variable. That is again the integer variable. Okay, because this is also returns integer data. Adding the brackets for simplicity. And we will display this I. Okay. Now this is into integer format. So here also you need to cast it into character for see the output. After this, you can display the system.out.println new line character. Okay. So I am displaying system.out.println file contents. Okay. So here we are opening this file into read mode. In the similar manner, only we are changing here using the file reader object. Okay, executing this. So you can see this is the example of reading a file. We have got the correct output. Now we will open a file in the same try with resources. You can open another file with the write mode also using the file writer class. File writer class, we will create the object file writer class. And suppose you want to open the same file into append mode, write mode, or read mode, then you have to mention this same name everywhere. Okay, so here I am going to use another name as test.txt. And this should be open into append mode. So same like a file output stream, we can pass here true for opening this particular file into append mode. So this is also inside the java.io package, file reader and file writer. So you can write the data, whatever the data we are reading here, okay, we will write the same data into the another file, okay, using write method. So what we will do, we will use the write method of fw.write, and we will pass this I integer byte data, so that whatever data we are reading from the particular this file test.txt, we are copying it to another file, that is, okay, I'm opening the same file basically. I will change it to abc.txt. Okay, so from test.txt we are reading, and from abc.txt we are we are writing. So we are performing the same operation here. So whatever the data we are reading into the I variable, we are same data writing into this particular variable. And we will write fw.write. One statement I will write using the string example of file writer append into file. Okay, this should be written on the new line, and then the next data will be displayed on the new line. Okay, so from here you need to see the output from here. Example, and then this one. So we'll see the output. Again, we are only displaying the system.out.print statement here, that is the character converted. So the data from the test.txt on the console. So this is the example of reading a file. We are getting this output. Now we will go to the abc.txt to see how our data is written. So you can see this is the example of the appending a file, and this whatever the statement we have read from the test.txt gets written here as it is. Okay, so this is how the reading and writing we are seeing here. So this first file is we are opening into read mode. Second file we have opened into append mode. Okay, using true, that means we are opening that file into append mode. Understood? The character stream classes, difference is only for the characters, nothing else. Or you can write directly the string data into it. Difference is only that. Other things, everything is same as the input stream and output stream classes. Clear? Any doubt?
So this while loop will read till the last character.
Yes, till the end of the file.
Okay. So how we have got EOF, right? End of the file.
Yes. When the -1 will occur, that means the end of the file is reached.
Okay.
So till the -1 byte is read, till that time we are iterating over that loop and reading each and every byte from your file.
Okay. So during the writing, if the file is already there and if we are giving a new file, sorry, if you are giving the new content, so is it going to get replaced with the old content?
I am not able to understand. Can you repeat your
Suppose if I'm having a file, I want to write into the file, but that file is already having some 2-3 lines of data. Okay. So if from the file, from this existing program, if I want to write it, not append mode, if I'm simply writing it, that write function, is it going to overwrite?
Yes, it will overwrite. It completely replaces the data from your file.
So old data is gone and new data will come.
Yes. So in that case, you need to open that file into append mode always.
So then only it will go ahead and append in the last one.
Yes, at the last, wherever your cursor is. If it is on the same line, the data gets appended on the same line. If you are adding the new line, then it will get appended at the new line, like here. Okay.
Whatever the cursor means?
Cursor means now we have completed our example here. Okay, so that means your cursor is at this position right now. So whenever you are appending any data, that gets appended here immediately at the same line. But if you are adding a new line character, /t characters like this, then it will get appended on the new line. By default, cursor is at this position right now. Okay, clear?
Yes.
Okay. So next is the buffered reader and buffered writer class. The difference only for this is there are few different methods into this buffered reader and buffered writer classes, which are used for reading and writing purpose. So the difference between the normal character stream and byte stream classes and the buffered reader classes, basically, it uses one buffer. Okay, so data gets whatever the data we are reading from a file, that gets stored into the buffer, that is a temporary memory first, and then it will be used. So same for writing also, the data gets written first into the buffer, and then the data will be written after the buffer is full, the data gets written into the file. Okay, so it is basically using one temporary memory that is known as buffer. So buffered reader and buffered writer. Buffered reader is used for reading purpose. So it reads the text from the character input stream itself and buffering characters so as to provide for the efficient reading of characters, arrays, and lines. So what we are doing here, we are opening a file and we are writing or reading the data or writing from a file byte by byte. Okay, so here, sorry, not this one. This one. Here we are reading using the while loop. Every time this method is calling the read method and it is going to the file. It is reading the current byte where your cursor is currently. Okay, that byte gets read and saved into this and perform the next operations in the while loop. Again, it will, for the next iteration, it will go to the file, it will read the next byte and then come back here, perform the next operations. So it will go ahead till the -1 occurs. So instead of this, using the buffer reader, you can use the simple example. So you can read the characters, complete file in a one go, and you can simply use all this while performing or to perform new operations. So it also has the read method, which uses it reads the single character as same as the reader classes. It also has the read method with character array size and offset and length one. But it has one more method, that is the read line method, which is mostly used in the buffered reader class. It will always use, or it is mostly used for reading a complete line from your file, a complete line till the /n characters occur. Okay, or wherever the carriage return is there, that is the /r character is there. So till that time, it is reading the data, storing into one buffer or temporary memory, and then perform the next operations. Okay, so it is easy to read the data from using this buffered reader. Okay, so we will see how to use this buffered reader. Similarly, we have a buffered writer class, which is used for writing purpose. So same as it also uses the character output stream classes for buffering characters. Okay, internally we have to cast data. We cannot directly instantiate these classes. We need to use the output stream or input stream classes or file reader or file writer classes to perform these operations. Okay, how to use that we will see. So thus providing efficient writing of single array, character and strings, we can use this buffered writer class. A buffer size needs to be specified. If we are not specifying, it will take the default size. The default size is, I know the size. I will give you 1 second. It is, I think, 8192 characters. The default buffer size is 8192 characters. Okay, so if you are not specifying any buffer size, it will take automatically. That is the default value. And we always use the default value itself. We never set the value for the buffer. And output is immediately set to the underlying character or byte stream by the writer. Okay, so there are write methods, new line method to add a new line, flush method and close method. So write method where you can add the data, string data, you can pass the byte data also. So we'll perform the operation reading and writing together, same as previous one, using buffered reader and buffered writer. So first we need to use try with resources, or you can use normal try block, and whatever the streams you are opening, you need to close it compulsory into the finally block. So here we will create buffered reader example. Buffered reader object br is equals to new buffered reader. Now you can see the constructor has a reader object. We should provide the reader object as a parameter to this constructor. That means we cannot directly instantiate it. So here you need to use file reader and the name of the file which you want to read. So I'm going to use abc.txt file for reading purpose. Okay, this throws the exception file not found and IO exception that should be caught. And again, we will open another file, or same file you can open into the write mode or append mode also. But I am going to open new file, buffered writer bw is equals to new buffered writer. Now here you need to, now here into the buffered writer, you need to add the writer object as an argument. Okay, so writer object, again you can use the file writer or file writer. For file writer, you can pass the string file name and the character boolean append. So file name I am passing here test.txt, and I am going to open that file into append mode. Okay, so we are opening one file, that is abc.txt, into read mode, test.txt into append mode, into the same try with resources. Okay, we are using buffered reader and buffered writer, so we cannot instantiate it directly. We cannot pass this file names directly to the buffered writer or constructor or buffered reader constructor. We have to pass the reader and writer objects to this. Okay, here now we will use same thing. We will read the file using the while loop. So the thing here is we need to create one string object. We are going to string a complete line of data from your file. So we'll create string line is equals to brand. Okay, now we will use this line line is equals to br dot read line method, which will read the complete data. And here you need to check is not equal to null. Unless and until this is null, here we never use the -1 because we are using this particular string data. That's why we are always checking it with the null. So unless this particular line or this while loop is returning null data, we are reading the line by line data from your file. So we will use system.out.println this particular line. Directly we are reading this line from your abc.txt. Now I will write some data using the buffered writer's write method, bw.write method. Okay, suppose the string I want to write. This is example of buffered writer write method. Okay, I'm writing this. I'm providing the slash in here so that this data will be appended at the new line. I'm executing the program now. So you can see all the content from the abc.txt is displayed here as it is. We are reading the data line by line. So, and we are displaying line itself, okay, string data. And now we will go to the test.txt. We can see this is the data we have appended using the buffered writer. Okay, so this is how the buffered reader and buffered writer works. Any doubt? Understood?
Is it like a temporary memory in which all these reading and writing happens? Because buffered buffer means something like a small memory we can imagine.
Yes. So it has 8192 characters buffer. This is the buffer size, default buffer size. It uses this unless and until this data is filled with this complete buffer, and then it will perform the read operations or write operations. So it is easy to perform these operations using the buffered reader and buffered writer.
So within this much memory only, whatever the operations are possible, we can do it.
Yes, but you can extend the buffer size also, but that is depend. If you want to extend the buffer size, if you want to change the buffer size, you can do that also.
Oh.
Okay, but mostly we never change the size, whatever this is a much bytes of data, right? Basically, not characters, it is bytes.
Okay.
Okay, so this is a much byte of data. So, and because we have only few lines of code, that means few bytes of data. So it is sufficient for reading and writing purpose right now. If you have more data, then you can change the size or you can specify the buffer size if you want. So it is basically using the chunk of characters is read from the disk and stored into the internal buffer, and from internal buffer characters are read individually. Okay, so data is read basically whatever the data from the file is read into the buffer first, and then from buffer it is showing you the data onto the console, or reading is happening from that buffer. Same for writing purpose also. It will first write the data to the internal buffer instead directly on the disk, and once the buffer is filled out, the writer is closed, then the whole characters in the buffer are written to the disk. So it performs this operation after closing this particular stream. That means we are using try with resources. So by default, it gets closed after we are completing this statement of write. Okay, it will get closed automatically. Clear?
I'm just trying to understand the differences like byte stream, buffered, as well as your character stream. If we are dealing with the byte stream, we are just trying to convert all the entire data into zeros and ones or bits, right? And then we are dealing it with the local memory.
So I will explain one more time. So if you are using byte stream, that means you are writing the byte data. Okay. So it is always into the bytes. If you want to store some string type of data, then you need to convert that data into bytes first. Then we can write it. Okay.
Correct.
Then the character stream. Character stream, we can perform the operations directly on the string, or we can perform directly using the characters, but it internally uses byte stream itself because computer doesn't understand the characters directly.
Yes.
We need to convert it into bytes itself. Okay, so bits is, you can say that. So though you are using the string, it is internally using byte stream to convert that string into bytes. Same thing which we have done. That is a get bytes method. Okay, so that is used internally. I will show you that. Suppose this is the read method from our, okay, it is opening the input stream class. We'll open the file reader read method. These are only, this is a public class file reader. It has only constructors, nothing else. Okay, so because all those are provided into reader classes, those methods are provided into input stream reader. So you can say this is the input stream reader. That means it is using input stream class, okay, which is a child class of reader. It is basically using internally, it uses input stream. Okay, input stream is nothing but which we have used. That is for reading purpose used for byte stream, input stream classes, file input stream, right? So same thing. So this is a reader class. It has a method read method, right? So here it is the method with the character array. And it also has a method string. It takes the string output. This is a normal read method, which we are reading character array, and then we are passing this to the another read method with the offset and character bytes. Okay, so this is a character array method where we are passing the character array. So it internally uses all this same method basically. And okay, it doesn't show the method implementation here. So internally it using the basically it uses this particular input stream class. So this is the input stream class for reading purpose, which is reader is using. Okay, so this is using internally all the same things, but it is again using bytes. Okay, it is converting everything into bytes and then performing the operations. Okay, so this is the file reader and file writer. Everything, these are reader writer classes that are working on the character streams, but internally again they are performing or they are converting into bytes. So you don't have to do that. It will get converted automatically. You can directly store the data like this into the string. Okay, so here this is a write method, string method. Okay, so this is a write method where we are passing the string data, offset and length, and this is using again it is converting into character array, and then it will get stored. So you can see that it is using getChars method, like we have used the getBytes method. Okay, so getChars method, it will convert the complete string into characters. Then each character will be written. That means basically you are writing the characters. That means again that character is byte, right? Converted into byte to store that data. So all things are using this internally bytes only, byte stream itself. Okay, so you don't have to worry about it. You can just, if you learn the byte stream itself, then that is also fine. Only the different classes are there to perform this, like file input stream, file output stream, file reader, file writer, and then the buffered reader and buffered writer classes comes. So these are also working with the character stream classes. These are also reader and writer classes, as the name suggests. You can see the name. It is also one of the reader and writer classes. So reader and writer, these are also child classes of reader and writer classes. So they are performing operations on character streams. Here, that's why we can read a complete line of string data from our file, okay, using read line method. Other methods are same, like read method, which we have already seen. The different method is only this one, where we are reading a complete line of data from file. We are basically storing this read line into a temporary memory that is known as buffer, and then after completion of this reading is done, then everything will be, whatever the data read into the buffer, that data will be displayed here, because we are using system.out.println statement. Okay, if you want to perform any operation, then whatever you are writing inside this while loop, that will get performed after read operation is completed. And the same for write operation. It is first writing the data, whatever the data you are writing here, that will get written into the buffer first. And after closing this buffer writer object, this whatever the data into this buffer is gets written into the file you have specified according to the mode you have opened. Clear? Understood the difference?
Yes.
So you can use any
stream. We are having so many streams, so got confused with the buffer and byte reader and all other things.
There are multiple classes. We have just seen few classes. There are multiple classes. You can use scanner class also for performing the file reading and file writing operation using the same methods like next int, next byte, next line methods. Okay. So there are multiple classes. We have only seen 3 to 4 classes, not more.
Okay.
Just remember that for byte stream classes, we have input stream and output stream class. For character streams, we have lots of classes: reading and writing for reading and writing, file reader, file writer, buffer reader, buffer writer, then data input stream classes, data output stream classes, object input stream classes, object output stream classes. There are a lot of classes. Okay, everyone performs the same operation because the main methods are defined into the input stream and output stream classes itself, which we have seen into the example. Okay. So methods are same everywhere. Only the purpose of that class will be different. We are performing the operations on file. That's why we have used the file reader, file writer. Okay. So if you want to perform operations on objects, then you can go for the object input stream, object output stream. Clear? Understood?
Yes.
Okay. So we will quickly see the next module's introduction, and we will see the program part in the next session. So the next module is with this buffered reader writer. We have already completed your file handling. Okay. The next module is your multi-threading. So multi-threading is basically we can create multiple threads. We can use the threads for executing simultaneously, okay, or concurrently, we say. The multi-threading thread is nothing but a small piece of code. So whatever the program you are performing, whatever the application you are creating, that application is divided into different multitasking small piece of codes. That is known as a thread. Okay, so multi-threading is specialized form of multitasking. Multitasking means your computer is also a multitasker. How you can open the Paint, you can open the Word, you can open the Notepad, everything at a one time, right? So the program, your processor of your computer or your laptop processes all these at a one time. That means this is a multitasking, multiprocessor. So how we say that multiprocessor, multitasking? Because all these are different processes and these processes are executed concurrently. They are executing concurrently. These applications are working concurrently. Same thing you can do into the multi-threading. So multi-threading is a specialized form of multitasking. Multi-threading program contains 2 or more parts which are running concurrently, and each part is known as thread. So you are converting or you are dividing into your complete application into a small program, and that is known as a thread. So difference between process and thread. Program and execution, whatever the program you are executing, that is known as a process. A thread is a part of a process. It is just a part of a process. It is not a complete process. Okay, processes are heavyweight and thread is a lightweight. Processes, each process has its own address space. That means it has own address space. It has memory allocated and that has a address. Okay, that's why we say that it has own address space. Threads are shares the address space, because it is a part of process. So whatever the process has address space, that gets shared among all these threads. Multiprocessing, more overhead. Multi-threading, less overhead. Processes or inter-process communication is expensive and limited. We cannot perform this inter-process communication, but we can perform inter-thread communication and which is less expensive. Processes context switching requires high cost, and context switching requires low cost. So context switching means we are switching our context into from one process to another process. Okay. Then, for example, process is nothing but a downloading files along with the listening music. You can perform at the you are writing something and you are listening to music. Also, you are surfing something on your web browser. So all these are multi-processes, right? So, but thread is nothing but in an editor, a character printing along with the formatting is in the same editor. You are performing some writing operation as well as you are formatting something. So we are basically converting us in the same process. We are performing our task in a parts. So that is you can perform using thread. The most important thing here is thread life cycle. Thread has 5 different states. First one is a newborn state. Second one is the running and runnable state. Third one is dead state and blocked state also. So when the thread start execution, when we create the object of the thread, it always into the newborn state. How to create object? It is a normal object. Okay. Once we start that thread will be ready to run. That means it will go to the ready state. That means runnable state. So it is ready to run. Then the processor of your computer, there is a thread scheduler. Okay, the thread scheduler pick up the thread according to the different criterias, like the priorities, the name given to that, and different criterias are there. So it will pick up the thread. The thread scheduler will pick up the thread and it will be go to the running state. Whatever the execution thread will be, that is into the running state. That thread we say it as it is into running state. Okay. So the CPU allocates or thread scheduler allocates the CPU for executing that particular thread. All the threads, whatever are newborn threads, once we start it, it will always are into ready to run. That means into the runnable state. Thread scheduler will decide which thread will be executed, who will get the CPU for execution, and who will be into the running state. So whatever the thread is into the running state, that thread is known as thread of execution. Okay. Then if we use this yield method, then again the thread will go to the waiting state and again go to the runnable state. Okay. Then there are different states into the block state, that is the sleeping state, waiting state, and suspended state. There are few methods like sleep method, wait method, and suspend method. So sleep method means whatever the thread of execution is, if you want to slip it for some particular time period, for given time period, so it will be pausing its execution, that will go into the sleeping state. Then after the time expires, it will automatically go to the ready state, and then the thread scheduler will pick up that thread for execution. Then the next one is the waiting state. When we use the wait method on that particular thread execution, it will block the lock, or it will lock the particular resource, or it will wait for the another resource that we will see. Okay. And once that time is over, or the when we use the notify method, it will go to the ready state. So if we are using wait method, you have to notify, or if the time period expires, it will automatically go to the runnable state, that is ready to run state. Last one is the suspended state. If you want to suspend that particular thread, then we can use the suspend method. It will go to the suspended state. And if you want to resume that execution again, you can use the resume method on that object. It will go to the ready to run, that is the runnable state. If you want to stop the execution at any point of time, you can use the stop method and your thread will be dead. So once the thread will be dead, you cannot execute or you cannot start the execution again. Okay. So this is the life cycle of a thread. It has 5 states. newborn state, running state, runnable state, dead state, and blocked state. Into blocked state, there are different ones, that is the sleep state, wait state, and suspended state. Okay, so this is all about thread life cycle. So the program we will see in the next session, how to use these methods and how to perform the operations, how to create the threads in the next session. Thank you. For today, we will end our session here. We will continue in the next week with the next points. You may leave. Thank you.